We're now going to look at addition and subtraction with different denominators, which has a few more steps. So let's look at those steps. First, we need to determine the least common denominator by finding the least common multiple of the denominators. Next, we need to rewrite each of the original rational expressions as needed in an equivalent form that has the LCD. And 3, we need to add, subtract, or subtract the resulting rational expressions as indicated. And lastly, we need to simplify the result if possible. Once we do that, we need to list any restrictions on the domain of a function. If it's just an expression, we don't need to worry about that, but if it is a function, we do need to list the domain of that function. Now, I mentioned this idea of a least common multiple. And so, just to refresh your memory, to find the least common multiple or denominator, least common denominator, find the prime factorization of each expression or denominator. Once we do that, we need to list each factor that appears in the factorization, the greatest number of times it appears in that factorization. If a factor is repeated, list this factor the highest number of times that it is repeated. Not every time it's repeated, just whichever one repeats it the most. Or you'll have way more factors than you need and it will be way harder. The product of all these factors is the LCD or least common denominator. So let's practice this on the function given here. I'm going to look at each one of my denominators and see if I can factor them, since the numerators are just numbers. I have an x squared minus 5x plus 6. That will factor to an x minus 3, x minus 2. I have an x squared minus 2x minus 3. This will factor to an x minus 3 times an x plus 1. And I have an x squared plus 4x plus 3. This will factor to an x plus 3 times an x plus 1. From here, I'm going to list my LCD, or least common denominator, by listing all the factors that appear the greatest number of times in each factorization. So think about these as separate things. If I look for x minus 3, it appears twice, but not in the same factorization. So you only take that factor the greatest number of times it appears in any one factorization. So I will only take one, x minus 3. Now I'm going to move on to my x minus 2. It appears once in the first factorization, and that is all. So I take one of those. Next, I look at the next non-highlighted factor, which is x plus 1. It appears twice, but not in the same factorization, so I will take the greatest number of times that factor appears in any one factorization. So it only appears one time in any one factorization. And lastly, I have this x plus 3. X plus 3 appears one time in one factorization, so we will take the x plus 3. This is my least common denominator. This is not pretty. I mean, it's beautiful, but what we have to do now is build up each fraction. So every denominator has to match this least common denominator here. So whatever is missing from each one of these denominators needs to be multiplied to both the numerator and denominator of the function so that they all have like denominators. I'm going to color code these to maybe help you see the process. You don't have to do this yourself, but I'm hoping that it helps you see where I'm getting the numbers. So as you can see, hopefully, the color coding shows that I have one factor of each color from all the different denominators, and that the denominators do have some factors in common, but none of them have all the factors in common. So what I'm going to do is build up the first fraction, just work my way from left to right, and multiply the numerator and denominator by the missing factors. X plus 1 is missing, and x plus 3 is missing from the first fraction. In the second fraction, x minus 2 and x plus 3 is missing. In the last fraction, x minus 3 and x minus 2 are missing. Now, hopefully you can see that I've now included all the different colored factors, so to speak, all the different factors from the least common denominator into each fraction individually, separately, so that all the denominators have the same 4 factors. Now I'm going to just rewrite the numerators with those missing factors. So I'll have 2 times x plus 1 times x plus 3 minus the quantity 4 times x minus 2 times x plus 3 plus 2 times x minus 3 times x minus 2. Now the denominators, remember, they all match. So I don't have to worry about them not matching anymore. I can just list them all out. X minus 3, x minus 2, x plus 1, x plus 3. Yikes. That's a lot. Now we have to distribute the negative after we FOIL each one. So 2 times x squared, outer and inner will give me a plus 4x, and positive 3, minus, now I'm going to distribute, well, I'm going to leave the 4 out, and I'm just going to FOIL first, x squared plus x minus 6 plus 2 times x squared minus 5x plus 6 all over the least common denominator. Now I'm going to distribute the numbers in and then combine like terms. 2x squared plus 8x plus 6 minus the quantity 4x squared plus 4x minus 24 plus 2x squared minus 10x plus 12. All divided by the common denominator, x minus 3, x minus 2, x plus 1, x plus 3. Now I'm going to distribute the negative through and rewrite it. Negative 4x squared, negative 4x, and positive 24. I'm going to now bring my like terms together. Minus 4x squared plus 2x squared plus 8x minus 4x minus 10x. And lastly, plus 6 plus 24 plus 12. All over the LCD. From here, I need to combine these. 2x squared minus 4x squared plus 2x squared, those add to 0. 8x minus 4x would be 4x, minus 10x would be negative 6x. 6 plus 24 plus 12 equals 42. And if I wanted to see if that would factor, if I did that, I'd get maybe even a negative 6. Let's try a negative 6 factored out. That will give me x minus 7, which doesn't actually or reduce with anything in the denominator. So this is my final answer. Negative 6x plus 42 all over x minus 3 times x minus 2 times x plus 1 times x plus 3. Now the last part is recognizing that this is a function. So we have to go ahead and write f of x equals this. And then we have to list the restrictions on the domain. So from before, vertical, asymptotes, at x equals 3, x equals 2, x equals negative 1, and x equals negative 3. So if you wanted to list the domain for this, it would be a very long interval notation, but it would be negative infinity to negative 3, union negative 3 to negative 1, union negative 1 to 2, union 2 to 3, union 3 to infinity.